Welcome to The Explainer. Today we are diving headfirst into one of the biggest challenges of our time. How do we actually guarantee the quality and, more importantly, the trustworthiness of generative AI? It's a question that is forcing us to completely tear up the old rulebook and rethink what quality even means.
This single question from strategic quality consultant Ibrahim Al-Sharif just hits the nail on the head. For decades, software testing has been all about predictable, repeatable outcomes. You put X in, you get Y out. Simple. But generative AI? It's the exact opposite. It's designed to be creative, unpredictable, and to change its answers based on context.
So we're not talking about a small adjustment here. This is a massive paradigm shift. We've gone from just measuring if a piece of code works to trying to measure if an AI is trustworthy. We're not just testing a final result anymore, we're trying to test the intent behind it. It's like we've moved from a world of rigid, predictable engineering to trying to evaluate a creative, almost conscious state.
So how in the world are we supposed to tackle this? Well, in this explainer, we're going to walk through the global effort that's underway to build a whole new rulebook for AI. We'll look at the new questions we have to ask, see how organizations like ISO, IEEE, and NIST are writing the rules, check out how the EU AI Act is turning those rules into actual law, and finally, what all of this means for engineering trust in AI.
All right, let's get into it. The very first step in this whole journey was everyone realizing that our old vocabulary, our old tools, they just weren't going to work anymore. We needed a completely new way to even talk about quality, something that went way beyond a simple pass or fail.
And that led to these 4 ideas, which have really become the cornerstones for this new generation of standards: explainability, transparency, bias freedom, and contextuality. Suddenly, the focus shifted from pure technical performance to something much more human: the relationship, the trust between us and the machine.
Okay, so how does this new way of thinking actually start to take shape? Let's begin with our first major player, ISO, the International Organization for Standardization. The best way to think of them is as the philosophers of AI quality. Their main goal? To make an AI's intent totally clear and understandable to us humans.
So the key word here is explainability. It's just not good enough for an AI to be right. We have to understand why it's right. The AI has to be able to justify itself, to give us its reasoning in a way that actually makes sense to a person, not just to another computer.
And to do this, they've developed these 2 key standards that are designed to work together. Think of them as the tools to help us pry open that famous AI black box. The first one, 6254, is all about making sure the model can explain itself. And the second, 12792, is about making its internal guts transparent enough for us to actually go in and have a look around.
And this is a brilliant example of how it works in the real world. Success isn't when the AI spits out a technically perfect reason. No. Success is when a real person reads that reason and understands it exactly as the system intended. So, if an AI rejects a loan and says it's due to credit history, but the user walks away thinking it was because of their age, the explanation failed even if the AI's decision was correct.
Okay, so if ISO are the philosophers, thinking about intent, then the IEEE and NIST are the engineers and the risk managers. They're a little less focused on the abstract why and much more focused on measuring an AI's actual behavior and managing its impact out in the wild.
You can see the different approaches right here. You've got the IEEE, which is all about translating big ideas like transparency and fairness into concrete things you can actually test and measure. And then you have NIST, which provides this big picture framework for connecting technical risks, like bias, directly to the real-world harm they could cause in society.
Now, what's so cool about the IEEE's approach here is how it makes something abstract like transparency into something you can actually build. It's all about creating a verifiable paper trail, an audit log where you can follow the breadcrumbs of every single decision an AI makes, all the way from the data it started with to the final answer it gives you.
And NIST? Well, they take this even further. Their whole framework is built around the idea that quality isn't a one-and-done checkbox you tick before you launch. It is a continuous, ongoing responsibility. You have to be constantly watching for things like hallucinations, for bias creeping in, and for how the model's behavior might drift and change over time.
So, we've got the big philosophical ideas from ISO, and we've got the practical engineering guides from IEEE and NIST. But how does all of this actually become something that companies have to do? Well, that's where the lawmakers step in.
The EU AI Act is a total game changer.
because it takes these technical standards, these shoulds, and turns them into musts, binding legal obligations. So the principle that AI should be transparent becomes a law that says AI-generated content must be labeled. This is what moves quality from just being a good idea for a company to a non-negotiable societal responsibility.
So let's just pull this all together for a second. When you combine these three layers, the philosophy, the engineering, and the law, you really start to see this profound shift in what quality even means in the age of AI.
And this right here is the absolute key takeaway. The goal is no longer just to build a tool that works, that performs a task efficiently. The real goal now is to build a partner that we can actually trust to be fair, to be transparent, and to be understandable. And there's a name for this emerging idea: human-aligned quality. It's this whole new standard for what success looks like. It's not just about the machine's accuracy anymore. It's a powerful mix of mathematical precision on one side, and on the other, a deep, cognitive human understanding that aligns with our values.
In the end, the success of this entire global effort, all these standards, all these laws, it's not going to be measured in lines of code or how fast a processor is. It's going to be measured by our collective ability to look at one of these systems and confidently say, I get it and I trust it. So really, the only question that matters is, what will it take for you to trust it?